So let us discuss this exam result of continuity. Okay. So in continuity, what have they given? F and G both are continuous at A. This is the given part, and as you can see on this board, we have to prove F plus G continuous, F minus G continuous, alpha F is continuous, and F into G is also continuous. So we call it as algebra of continuity. Already we have done algebra of limits in our previous videos, right? So see, there is a very minor difference between definition of continuity and definition of limit. So just by watching our previous videos of algebra of limits, you can prove the algebra of continuity also. So what will we do in this video? I'm going to prove just one of it. That means I'm going to prove simply F plus G is continuous here. So you have to prove F minus G, alpha F and F into G, all of them are continuous. Okay, so let us start to do. So as you know, epsilon delta definition of continuity. So here we require epsilon first. So I'm going to take one epsilon here. So let epsilon greater than 0 be given. Okay, so I'm taking one epsilon first, right? Okay, I hope it is visible. Okay, so what is the first information we have? I will write f is continuous at A. So what we have, if it's continuous at, that means I will write limit x tends to A, f of x is equal to f of A. So in case of limit, we have L here. You are getting my point. In case of limit, we have L, but when the function is continuous, okay, we write f of A. Okay. So let us apply the epsilon delta definition. So therefore, by definition, what can I write for given epsilon? But epsilon already we have taken. So I will call it as for above epsilon. So therefore, for above epsilon greater than 0, there exists delta greater than 0 such that what can I write? Norm x minus a less than delta implies mod f of x minus f of a less than epsilon. A very small adjustment I am going to do. That is, instead of epsilon, I am going to take epsilon by 2, a small adjustment. Okay. So see, this is equation or expression number 1, I will say. So one first information I use, that is f is continuous A, as well as we have a second information that is G is also continuous at A. So we have, I will write here, we have G is continuous at A. That means that is limit x tends to A, G of x is equal to G of A, right? So see, LM we had when we were discussing the results of limits. So here we have f of A and G of A. So let us apply the definition of continuity again. So therefore, what can I write? Therefore, for above epsilon greater than 0, therefore for above epsilon greater than 0, there exists delta greater than 0. But the problem is delta already we have taken. So for I will write here delta 1 and I will call it as delta 2 such that, tell me such that, what can I write? Such that, again definition, norm x minus a less than delta 2, here I should write delta 1 implies mod, right, implies mod g of x minus g of a, minus sign is here, less than epsilon, but again adjustment, epsilon by 2. See, expression 1 is true for delta 1, right? Expression 2 is true for delta 2, but we want both expressions should be true simultaneously. So what will I do? I will take minimum of both of them. So 1 and 2 will be true simultaneously and we can use, right? So let delta is equal to minimum of delta 1 and delta 2. So 1 and 2 will be true for it. Okay. So therefore I'm going to consider for norm x minus a less than delta, then we have to prove f plus g continuous. Now that means we have to prove f plus g of x minus f plus g of a, right? We have to prove that it is less than epsilon, then we are done. That means prove that f plus g is continuous. So we should consider its mod, and we have to prove that its mod should be less than epsilon. Okay, so let us simplify it first. So see, obviously I will operate f of x plus g of x minus here f of a. See, plus g of a, but there is minus sign outside, so that's why minus g of a. After that, we will form pairing. That means f of x and f of a I will collect, and g of x and g of a I will collect. So therefore, mod f of x minus f of a plus g of x minus g of a. After that, I will take separate mod. But as you know, if you take separate mod, probably value will get increased. So that's why this is less than or equal to mod f of x minus f of a plus mod g of x minus g of a. Right, so mod f of x minus f of a, we have got it, okay, in expression number 1. So it is less than epsilon by 2. So I can write this is less than epsilon by 2, and mod g of x minus g of a also we have got it is less than epsilon by 2. So if you add, you will have epsilon. Okay, so therefore I'm going to conclude, okay, the proof of this theorem. But before that, my screen is over, so make a screenshot of this screen, and after that we will go for next part of it. Okay, see, therefore what can I write? So therefore norm x minus a less than delta. Okay, this thing we had considered, and finally what we have got implies I can write mod f plus g of x minus f plus g of a, and it is less than epsilon we have got, right? So therefore, by definition of continuity, I can say f plus g is continuous at a, or we can write the same thing in this way. Therefore, that is limit x tends to a, f plus g of x is equal to f plus g of a. So therefore, I can declare, therefore f plus g is continuous at a. So in this way we proved f plus g is continuous, but still some tasks are remaining. That means f minus g is continuous, alpha f is continuous, and f into g is also continuous. So you have to prove these remaining three, that we have to write their proofs. And if you want, you can watch our previous videos of algebras of limits, so you can get a hint from that, and by making some minor changes you can easily write their proofs. Okay, so make a screenshot of it, this one, and after that we will stop. Thank you, bye bye.